You're listening to the Uptime Wind Energy Podcast, brought to you by BuildTurbines.com. Learn, train, and be a part of the clean energy revolution. Visit BuildTurbines.com today. Now here's your hosts, Alan Hall, Joel Saxum, Phil Totaro, and Rosemary Barnes.
Well, you won't want to miss the next SkySpecs webinar, which is on April 30th at 11 a.m. Eastern Time, U.S., which, Joel, that's like, it's like 5 p.m. Denmark time, right? Roughly? Yeah, and this is the second webinar in the joint series with Uptime and PES Wind. This edition features industry-leading repair vendors and discusses the latest trends, challenges, and innovations shaping the turbine repair landscape. Now, this is who's scheduled to appear. Cheryl Weinstein, Principal Blade Engineer with SkySpecs, and if anybody knows Cheryl, she knows blades. This is somebody you want to pay attention to. Alice Lyon, owner and CEO of Lyon Technical Access, really knowledgeable about blades. Craig Guthrie, who I've known for a long time now, Director of Blade Service at Tachyon, and Jose Israel Mejia Rodriguez, who's Director of Engineering at Renewable. And if you've worked with Renewable, they do a terrific job keeping turbines up and running. So this discussion will be talking about best practices for operators and owners and repair teams. There's a lot of confusion at times on how to keep your organization running smoothly. Well, these experts are going to be giving you a lot of good advice and how to source repair vendors and how to evaluate vendors and get certifications and safety records, which are getting more and more critical as the season goes on. So you won't want to miss this. April 30th, 11 a.m. Eastern U.S. Click the link in the show notes below to register for that event and tell a friend, because this is going to be a great webinar. Ørsted has released a significant new report titled Offshore Wind at a Crossroads, and you can go on Google and download this document. It's a pretty thick white paper, and it examines the current state of the European offshore wind industry. And Rosemary and I were just over in Copenhagen. We saw a lot of the offshore wind industry at the Wind Europe event. Now, the report focuses on the urgent need to revitalize Europe's offshore wind industry, and it outlines the policies and industry action required to unlock investment and stabilize some of the costs and accelerate the deployment of offshore wind. There are a number of highlights in this. One of them or two of them, let's go with the big ones, which is Ørsted proposed a joint commitment between the governments and industry to auction at least 10 gigawatts of CFD capacity over the next 10 years. So 10 gigawatts per year over the next 10 years, which would be 100 gigawatts, plus another 5 that would be for corporate offtake, so like a PPA sort of situation. And for doing this, with that commitment, the industry would then mobilize investment to try to lower the levelized cost of energy by 30% by 2040. And my first thought was, boy, that's a pretty good trade-off. If I'm any country in Europe, 30% is a lot, because the existing CFD prices are in the 90 euros per megawatt hour, and then we're going to try to drop them into the 60s, 70s by 2040. And my first thought, no, I was going to talk to all of you today, was, is this possible? Do you think they can get a 30% reduction by 2040 in the levelized cost of energy for offshore wind? Some of that coming from lower cost of access or easier access to cash, which hopefully, if interest rates comes down, that will happen. The other one is just getting better at what they're doing. Is that something that we can lower the price down that much by 30% by 2040?
Well, yeah, they target two areas in this report that they talk about. Reduced cost capital being 15% of it approximately, and the other 15% being, as you mentioned, like what they're calling accelerated learning curve, which is really just what do we used to call that? Economies of scale. Effectively, like getting familiar with the manufacturing process around certain things and being able to get cost efficiencies out of wasted manufacturing process or wasted materials and things like that as well. So the short answer is I don't know that it's going to be 30%, and I would actually forecast that the reduced cost of capital will probably be more than 15%. So you may get there, and you might get to 30% reduction just on cost of capital alone, but at the end of the day, yeah, I mean, this isn't anything revolutionary here. So, yeah, it's certainly possible to be able to achieve that, especially by time frame like 2040. But we also don't know what's going to happen, in the global economic situation between now and then. That's 15 years away, 14 years away, and there's some black swan event that's still out there yet to happen that can throw us into a global recession or also into global growth. So we'll see.
Black swan is such a weird phrase for an Australian because all swans here are black, and so
The last person that used that with me was an Australian.
I think there's a couple of things you can think about here, though, too. If what this is calling for, what this report is calling for, is stability within the industry. We want stability. We want to have more growth. We want to have more opportunity. We want a market and a power producing industry for offshore wind that is stable and can drive investment. It can take investment. But if you get to that stage, you're also going to bring in more competition, right? That's good. So if it's a stable space and more people can enter it to work in it, then you're going to more competition usually drives prices down, whether that's vessel manufacturers or suppliers or blade repair companies or drone inspections, whatever that may be. More competition usually drops that price. And at the same time, ever since I've been in the wind industry, it's been really exciting about how we treat innovation. There's a lot of people working on a lot of things. And if in the next 15 years, innovation, the whole point of innovation is to drive prices down or to save money here, save money there. So I think that more competition in a stable market, more money coming into innovation in a stable market. This is outside of what Phil's thoughts that are completely correct on, financing coming down in cost. I think that those things could drive an LCOE down. It's that economy of scale. It's that once we're here, we're ready to roll, we can do these things.
I might kind of disagree with Joel, but probably at its essence, not fully disagree. I think that definitely, I mean, it's not actually a huge reduction over 15 years, right? Like if you look at the previous curves of cost reductions, it's not going to even continue that trend. But I do think that the recent trend, or up until a couple of years ago, the trend for wind energy's price reductions was too steep, artificially steep, and I think driven by like excessive competition or like a weird kind of competition with maybe too much innovation in a sense. So I think that more of the same of that is not the right kind of innovation. I think what we need is to have a few products available. Definitely you need some competition, but companies need to be able to make enough turbines from the one platform to have a secure pipeline of projects. Then you get the kinds of innovation that maybe don't immediately seem like innovation, but are nonetheless, like just little learnings on how to improve cycle times, little learnings on how to improve quality, just tiny little engineering innovations, manufacturing innovations that just have time to build up, have time to repay all of the, like you need a lot of engineering to make a new product, an offshore wind product, reliable and cheap, and you need enough units made to repay that investment. Because when you just constantly, like a new platform every year, we're going bigger this year, 2 years later we've got a bigger wind turbine, and 2 years after that we've got another bigger one. It's not enough time to make enough wind turbines to repay the engineering investment.
And I think, Rosemary, I agree with you 100% on that component. And where my point was more driven, and I should have said this, was more innovation in O&M.
Yeah.
Like I'm thinking in operation of wind farms is my take on innovation is more innovation in the operations and maintenance. How can we do this better, faster, more efficiently with robotics or whatever that may be? And so that's where I was going with it rather than on the development or OEM side.
But O&M is downstream of OEM, and getting the OEM to deliver a high quality product is the key here. Rosemary, give me a rough estimate on a new development cycle versus continual improvement engineering staff. What is that ratio? Is it 10 to 1 when you're developing a new turbine? You need, say, 100 engineers to sustain it and make it better. Do you need 10? You need 20? You need 30? What is that relative number? Because that's where a lot of savings is going to happen, really, is reducing the staff and getting more into the manufacturing and focusing there, right?
Yeah, I mean, it would be a total stab in the dark based on my personal experience, probably not totally representative, but it varies so much from product to product depending on what kinds of innovations that you've got. Senior management at engineering companies love to think that the, like lower level engineers, project managers are just, just like to complain and are too risk averse and all that sort of thing. But us engineers, back in 2016, 17, 18, like we were right. It was too fast, and too fast for the amount of engineering support, and we see quality problems now. So I just think like if the industry can't take another, we'll get through this crunch now with increased quality problems, increased warranty costs. The industry will get through it, but you can't have another cycle again in 5 years' time from that. You need time to consolidate and rebuild trust in the industry and in the technology. I think in the West we misunderstand what counts as innovation to think it's only scientists in labs that are innovating. It's only those eureka moments of a new cell chemistry or a new battery chemistry. That's what counts as innovation. But if you look at the cost reduction, actually most cost reduction comes from those like small, boring manufacturing innovations. And not just with manufacturing the product itself either, innovations in terms of, installing wind farms, and innovations in operating them more effectively can make a huge difference. Innovations in project financing as well can have a really big effect. Like Phil mentioned, like the finance cost is one of the easiest or most likely ways that we'll see cost reductions actually. So we need to broaden our thinking on what kind of innovation that we need, I think.
I want to take a quick break here, and when I come back, I want to understand how more European supplied components, that is obviously going to happen over the next couple of years, are going to be able to support this 30% reduction in the LCOE. Is it possible? Don't let blade damage catch you off guard. Eelogic's ping sensors detect issues before they become expensive, time-consuming problems. From ice buildup and lightning strikes to pitch misalignment and internal blade cracks, Eelogic's ping has you covered. Their cutting-edge sensors are easy to install, giving you the power to stop damage before it's too late. Visit eelogix-ping.com and take control of your turbine's health today. All right, we're back. So Rosemary just led a really good discussion about the ways and methods that LCOE is going to get lowered on offshore wind in Europe. One of the sticking points, I think, though, is there's going to be more emphasis on building more components within Europe, which has a higher cost structure. Can the European manufacturers, Vestas, Siemens Gamesa, push down prices if they bring more of the components from Europe, instead of having so many produced in China or in India or wherever they're going to be produced at? I do feel like there's going to be a big push to make some of these things in Europe. Is that going to offset the savings they're making on the installation and the design improvements? Is there a way to do it, Phil?
Potentially, but only with reductions in labor cost, which, we've talked on the show before about, unionized labor around the world, but I mean, Europe has probably some of the most heavily regulated and largest overhead associated with their kind of unionized labor there. So unless they're going to soften on that side of things and find ways to reduce overhead, the short answer is no. The second element of this is raw material costs, which is where we could still leverage. And I've talked about this on the show a number of times. We could leverage raw materials from China, raw materials from other places around the world, in exchange for, reductions on tariffs for steel imports, in exchange for more access to, the European market. And I've said that about the United States as well. It's like, all right, well, if the Chinese want to come over here, they can, but they've got to give us more rare earth elements, to processed rare earth elements. They've got to lift their quotas. So it's got to be something like that. Those would be really the two easiest scenarios to get to a production cost in Europe that would be comparable to what people could get in India or China. But without that, I don't see what incentive companies have to re-domesticate production.
Is automation going to play a part in that? When we were over in Wind Europe, there was a big celebration between Pimamec and Windar. So Pimamec makes the automated welding machines that are welding really thick steel plate together to make foundations and towers, super complicated things, but it's automated. And to roll the steel, not easy things to do, but it's automated, and it really lowers the cost down and making towers when they use these automated tools, these computer controlled tools. Is that where the industry is going to go? That we're going to see more automation, more robotics, more AI kind of technology thrown at these problems to lower the cost of these parts down?
I think so. And we're talking a 15-year time frame as well. It's one of the things like with the wind industry that the whole time that I was working at a manufacturer, like automation was being introduced to every kind of industry, but everybody in the wind industry was like, "Oh, we can't automate wind energy. We tried, and it didn't work." And that, we wasted I don't know 10 million euros or whatever on a project to automate wind turbine blade manufacturing, so it won't happen. And it's just like, well, okay, but you tried in 2010, and now we've got 2020 technology, and soon we'll have 2030 technology, and like obviously the whole world is not going to automate except with the exception of wind energy. So I think that there are now, I did talk to several people at Wind Europe, even from OEMs that are working on automation projects now. And so we are going to see either incremental improvements where they just, automate certain parts of the manufacturing process, or my personal belief is that we will actually see maybe even a revolution in the way that a lot of wind turbine components are made to be fully automated and a totally different manufacturing process than what we've seen. And if that happens, then it goes from being you got to locate the manufacturing where the labor is cheapest, then other factors will be more important, like what's close to the site that you're installing, because shipping is a large cost, especially for large offshore wind components, and energy will be a larger cost probably for automated manufacturing. So low energy costs will be an issue. So I do think that we're maybe not 5 years away, but sometime in the next decade, I predict a big shakeup in the way that the industry works in terms of manufacturing for wind energy, and we need it as well. That's something that's got to happen to get the costs down to the level that we need them to be to roll out the amount that we need to have.
And when you introduce automation into any kind of industrial process, it's not going to immediately drop the end price. A lot of times there's a bit of capital, a bit of NRE that happens with that. And like something nobody wants to go in and start losing, or like as a supplier, nobody wants to go in and then take a lower price point right away. So that price point will remain high when automation is first introduced. And what the push is going to be is it's going to control quality. You talk about this Pimamec thing and the Windar renewables. You're like, it is so hard to weld, as someone who can to weld thick, heavy steel together and to have it be perfect or right, or that's so difficult. That is an art meets science thing. And when you can do it in an automated fashion, then your quality goes up. That's what we want in the industry. And it's going to it'll be a great snowball, because once we get in there, we get the automation going, we get quality going, and then after this machine is basically depreciated, then it gets cheaper as we go. So this is the exact direction we need to go in.
Theoretically, but I'm gonna take maybe the contrarian approach to this and say, what normally happens is what Joel just described. You've got non-recurring engineering cost and upfront capital costs that usually make something or keep something as expensive or make it even more expensive than it otherwise would be. But over time, as the economies of scale are achieved and the depreciation on the equipment occurs, it's not like we get a reduction in the cost. We just get companies that get bigger margin as a result of leveraging that automation and technology. The other point I'll make is to go back to this concept that the only reason we haven't seen automation more widely adopted today, because we have a lot of the technologies in place. Not all of them, you still can't automate like everything, and just have a factory of robots making wind turbines. But the reason we haven't adopted it today is because of the cost of production. Yes, you might get higher quality, but the cost of production actually wouldn't be lower than using people power. And that's something that, so just like you get economies of scale with the components you're producing, the automation itself needs to go through a cost revolution to be able to get down to a price point where it can be more widely adopted. And that's one of the main reasons why it hasn't been.
As busy wind energy professionals, staying informed is crucial. And let's face it, difficult. That's why the Uptime Podcast recommends PES Wind magazine. PES Wind offers a diverse range of in-depth articles and expert insights that dive into the most pressing issues facing our energy future. Whether you're an industry veteran or new to wind, PES Wind has the high-quality content you need. Don't miss out. Visit peswind.com today.
Well, if you haven't downloaded your latest copy of PES Wind, you need to do it now by visiting peswind.com, or you can actually ask for a hard copy. Hard copy is brilliant if you can get one. They're hard to get your hands on lately because everybody keeps grabbing them at all the trade shows before I can get to them. But hey, what are you going to do? And in this quarter's PES Wind, a lot of great articles. And one that I knew was coming for a while is from Hardhead Veterans, Joel, down in Sweetwater, Texas. And they've been developing a safety helmet, for wind technicians. And I saw this probably a year ago when the development started and they were head on this project. This is cool, neat technology. And so it's a heavy safety helmet. And it has better protection from both top and side impacts. And the whole goal of this is to have a better performing, better comfort, and especially in Texas where it's so dang hot. You want a helmet that does cool you, and Hardhead Veterans have done that in numerous industries, but now they're into wind. This is pretty cool.
I think that something that people don't realize with safety gear or PPE in general is being a wind turbine technician is very specialized, right? So just look, we're focused on hard hats here. So you need to be protected from anything falling from above. You need to be protected we call them bump caps, right? So when you're inside of a nacelle or you're climbing a ladder or whatever, and you bump into something or on the side of the head or the top of the head, you need all that protected. You also need a chin strap because where the wind blows. That's where we put wind turbines. So you need all these things. But then they've gone a step further, and these are some of my favorite components of hard hats in general. And I've always said these things. Connected tools, right? So now you've got this thing, you can put ear protection on it, you can put sunglasses on it, you can put a headlamp that's built into it. And my favorite feature, now I'm an old school hard hat guy and I have been since my oil field days. I like having the brim on the sides to protect my ears from the sun. I hate getting sunburned. And they've done like literally everything I like about a hard hat is in this hard hat, and they're making them in Sweetwater. I think this is a fantastic product, and these guys are going to see some high demand. Hopefully the Uptime bump helps for their bump caps, and then they start making a lot of sales because they look awesome.
If you go to the website, which is hardheadveterans.com, you can see all the different colors of the heavy hard hat. They come in all kinds of great colors. And I'm sure, is there a requirement, Joel, to have a specific color on site? I know most of them are white, but
it depends on the operator, right, too, because some of them will be like short service employees need a certain color. Sometimes it's someone who's a regular technician on the site. They have a regular color. Guests have a different color. Yeah, you're correct, Phil. So that's going to be company by company, but I know that I'm a fan of the old school white hard hat. Keeps you cool in the sunlight too.
Yeah, when Joel and I show up at wind sites, they give it the helmets with the flashing red light on top to know that we don't belong there. Do not let these guys climb a turbine today kind of hat. Yeah. And rightly so. Yeah, so check out PES Wind at peswind.com, and also visit Hardhead Veterans website. It's really cool stuff there.
Please send me a hard hat with a Padloat logo on it.
Rosemary has a very special announcement. Go ahead, Rosemary.
Yeah, my little YouTube channel got past 100,000 subscribers a month or so ago. So now I've got my very own play button on display in my background to go with WeatherGuard one from ages ago now, 2 years ago, and soon to be joined by a gold version of the button to celebrate 1 million subscribers on the Uptime Wind Energy channel, which is a mind-blowing number of people around the world who are interested in all the news in wind energy, and which you can find handily combined in one place.
It's WeatherGuard Lightning Tech on the YouTube channel, because that's how we started it way back 5 years ago. It was like a little company channel. We were hoping to get like 1,000 people to subscribe at the time, and now it's 1,000 times that.
For this week's Wind Farm of the Week, we're heading to New Mexico. The La Joya Wind Farm in New Mexico is owned by Avangrid. The completed project, which is 2 phases, will have 111 turbines in it, and they are built now. So it has 76 GE 2.8 127s and 35 Siemens Gamesa 2.6 114 meter rotor machines. So the project is located about 10 miles west of the village of Encino. An interesting thing here, which if you've worked in wind and you know anything about New Mexico, it's one of the few places in the U.S. that puts wind farms on state-owned and public land. So this wind farm is partially on New Mexico land with 74 turbines, 207 megawatts of that generation on that state land, which Avangrid won in 2019 through an open bid process, which is a pretty cool consideration. So this project will raise over $41 million for New Mexico public schools, which is fantastic. And one of the things I want to highlight here is that I was looking Wind Farm of the Week, and I found an article, and this is from 2020 when this wind farm was first being built, and it focused on building it during COVID and stuff, and some really cool things they did there. But back then, the PNM, which is the local grid operator there, the vice president, Tom Falgren, said, when integrated with our wind, solar, and battery storage, PNM is well underway to not only meet state's emissions-free mandate, but well positions us on the path to 100% carbon-free by 2040. So I know that battery storage has been battery storage the last year or so. But back in 2020, this wind farm, and when they kicked this thing off, they were talking about it already. So New Mexico, a little bit ahead of the curve there. So the Joya Wind Farm in New Mexico by Avangrid, you're the Wind Farm of the Week.
That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please check out Uptime Tech News, our Substack newsletter, which you can find in the show notes below. And check out Engineering with Rosie, who has reached the 100,000 subscriber stage, headed to the millions. And we'll see you here next week on the Uptime Wind Energy Podcast.